Hi, good morning or good evening, depending on your time zone. My name's Ken Tune. I'm a member of the Solution Architecture team here at Aerospike, and today I'm going to talk to you about managing cluster lifecycle without downtime. I'm joined by Meher Tanjukian, our VP of Customer Support, who will be helping me out in the Q&A at the end. Okay, so let's talk about downtime. You'll hear people talk about 5 nines, 6 nines, etc. Let's start by looking at the arithmetic to see what those things really mean. A database that only guarantees you 99% uptime is pretty much no good. That corresponds to 3.5 days of downtime in a calendar year. 99.9% guaranteed uptime will give you nearly 9 hours of downtime in a year, 99.99%, around an hour, 99.999%, 5 minutes. Only when you get to 99.9999% uptime, that's 6 nines, do you get to uptime that starts to look acceptable to a major business. And even then, do you really want to have to worry about that 30 or so seconds in the year? And realistically, how can you know that your product gives you 6 nines and not 5 nines of uptime, noting there is a big qualitative difference between those two things? What you really need is a product that has the goal of giving you 100% uptime. And that is a tough goal. But at Aerospike, that's what we do. It's easy, in inverted commas, to build a product that's 99% available, 99.9% harder again, 99.99% harder still, and so on. But that is the difference that we offer. Now, uptime or downtime is often conflated with reliability. But reliability, while being a good part of the story, is not quite the catch-all it sounds to be. Reliability really refers to avoiding unplanned downtime. And it's fantastic to have a product that will deliver that, and Aerospike does, but what about planned downtime? Well, of course, you don't want planned downtime either. From a user perspective, experiencing planned downtime is just as undesirable as experiencing unplanned downtime. From a business perspective, it's stressful to manage. It usually needs to be done at an off-peak time, if there is such a thing in a 24-hour world. That will typically be during antisocial hours, weekends, 2 a.m., that sort of thing, which insomniacs aside, I think we would all agree is not great. It will end up having many eyes on it, so it's costly at the time of execution, as well as during the planning activity that precedes it. And there is always the risk that it will take longer than expected, or that some previously unconsidered side effect will cause problems at best, failure at worst. Also, planned downtime. Even if you only have 1 hour's planned downtime in the year, that's actually the equivalent of running at 3 nines reliability. So in short, not only do you need a product that gives you 0% unplanned downtime, you also need one that gives you 0% planned downtime. And in this talk, I'm going to look specifically at the Aerospike features that ensure that you don't need planned downtime either. So let's take a look at the operational procedures that might require planned downtime. Addition of capacity, removal of capacity, product, that is Aerospike upgrade, operating system patching, server maintenance, cluster migration. With Aerospike, you can do all these things without your users ever noticing and without introducing risk if you do it the right way. The right way involves using a command called quiesce. Quiesce was introduced into the Aerospike product in August 2018 in version 4.3. When you issue the quiesce command, it tells the node in question to hand off master and replica responsibilities after the next recluster event. Just so you can understand the difference that this makes, I'm going to show you what happens if you don't use quiesce.
First of all, we're going to take a look at the status quo
via ASADM. We can see that our 10 million records are split 3 ways across our 3 nodes, as are the replicas. Okay, the next thing we're going to do is we're going to issue a quiesce. And then we're going to issue a recluster. It's the entire cluster. Okay. And now here we can see that the master responsibilities have been handed off. So this node, this is the one I'm on, no longer has any master responsibilities. You'll also see that its replica objects have been classified as non-replicas. Okay, so we have now effectively quiesced our node, even though it is still in the cluster. We can also see migrations taking place as the cluster proactively readjusts. I've got my reads and writes still going on in the background here. Throughout, the 2 operations that I've just executed, we've not had a single client error or a server-side error. The thing to note is that the host is still up, even though it's not really participating. That's what quiesce is all about. So I'm going to exit ASDM, and now I'm going to stop my node. Okay. So you will see the cluster size drop to 2. There you go. Migrations were already happening, they're happening proactively. But you'll recall that last time, when we stopped the host, we had, this kind of relatively small number of server-side timeouts, client-side errors, and we just don't see any of those this time. So what we've done is we've cleanly taken the node out of the cluster, effectively with 0 impact whatsoever. Worth noting again that the throughput level remains absolutely constant. Okay, so I'm going to restart my node. And once it rejoins, I just want to draw your attention to the fact that introducing a node back into the cluster doesn't generate errors either. Okay, so it's ticked up to 3. The migrations are now moving in the opposite direction, sort of allowing the fact that we have delta migrations taking place, related to content which was injected after the server stopped, which will ultimately be mastered by the server which was stopped and started. And the key thing is, again, no server-side errors, no client errors, no change in throughput. So what we'll do is we'll leave the cluster to get back to its original state, and then we'll move on to the next topic.
Okay, so what happened just there was I actually showed you slightly the wrong video, but it doesn't matter too much really. So I'm going to show you what happens if you don't use quiesce. That's what I intended to do. Just now I showed you what happens if you do use quiesce. So you've got everything going through cleanly without seeing any failures. So what I just did, the problem we're trying to solve is taking things down gracefully without getting any errors. The sequence of commands that you need to execute that were effectively executed in that last demo was asinfo -v quiesce, which tells the node to hand off master and replica responsibilities at the next cluster event. And you do that by doing asadm -e asinfo -v recluster. And we create that cluster event using the recluster command. And what I also want to do is just provide a clarification about
writing. So I'm doing updates, not writing, so I can keep the total object count constant during the demo. Otherwise, it's very confusing to see if things have worked accurately. It just helps you see a little bit more easily what's going on. That's why the number of objects doesn't increase in response to writes. So what you'll see next is what happens if you don't use Quiesce. So I'm sorry that it's the wrong way around, but hey, that's live television for you. So let's video.
What you're looking at here is a Grafana dashboard receiving Aerospike cluster data from the Aerospike Prometheus exporter. I've got a 3-node cluster with replication factor 2 enabled. I've loaded 10 million objects, so I have 10 million master objects and 10 million replica objects. I can see where the migrations are happening. I can also see a history of migrations and cluster size. The dashboard also lets me see the rate of successful reads and writes. It will let us see the rate of any server-side read or write timeouts and errors, also read not founds. And finally, it will let us see read and write timeouts and errors on the client side. So previously, I've started some read and write activity using our benchmark tool. You can see we have 5K reads per second and 5K writes per second in the terminal window. You also see counts of read and write timeouts and errors on the client side. What I'm doing is I'm teeing this output to a log file, which I'm feeding into a Prometheus agent, and that's what lets me see client errors in the Grafana dashboard. So as before, here are our reads and writes going through. No server-side errors, no client-side errors. So what I did just there was I stopped one of the Aerospike processes, so effectively taking a node out of the cluster. The agents collect data every 15 seconds, so it takes a little while to see the results, but there they go, straight away. So the first thing that happens is the number of master objects drops, and then it will go back up, which is an artifact of the sampling of the agents on each host not being completely synchronized. Wait for it, there we go. We also see some write timeouts on the server side and some write errors on the client side. The cluster count has fallen to 2. We have migrations taking place. Aerospike's resilience capability means that we didn't see a single read error in the process of effectively losing a host in the cluster. And remember that we're running at 5,000 reads and writes per second. So with a 3-node cluster, losing a host statistically, we would see those in this run if those things were happening. And that's because with replication factor 2, every partition has 2 copies, and the reads will fail over to the replica partition for the partitions that were mastered on the host that we took down. What we also see is migration. So the software takes care of reallocating master and replica responsibilities and creating new replica partitions where needed, which is why you see the replica object count rising over time. So that's almost all good. The TPS rate stayed flat. We had no read errors, we had no read timeouts, and we had a transient blip with the writes. So we had some write timeouts on the server side and some write errors on the client side before normal 0 error behavior was restored. So what's going on here? Well, with writes on the client side, if a node stops, I may get write timeouts on the server because some in-flight writes will not be able to replicate to the now stopped host. And these will be returned to the client as errors because the transaction couldn't be completed. So, wouldn't it be nice if we could get rid of transient write errors as well? And we can do that using a mechanism called Quiesce. And what quiesce will let us do is it will let us take a node out of the cluster gracefully. So let's move on to that.
Okay, so apologies for the confusion there. Two very similarly named video files, but hopefully you kind of get the idea. You see, what it is that we're trying to prevent, and you see what it is that quiesce solves. And although it might seem like a small thing, quiesce is sort of really powerful. I hope you can see that it will allow me to take down any node I like, OS patch it, put new DIMMs in, whatever, bring it back up, and no one will be any the wiser. So no scheduled downtime necessary. And what these demos have also shown you is that you can add and remove capacity seamlessly. And we could also use this mechanism at the command line to round-robin upgrade our Aerospike servers. But what I'm going to show you next, though, is a little bit cooler still. We're going to Ansible script a product upgrade of the entire cluster, during which time there will be no errors or timeouts despite ongoing database activity. Let's talk about what our script will do. Just say a little bit about Ansible. So first of all, before I move on, if you haven't used it, Ansible is a great way of managing DevOps activities, and I recommend you try it out if you haven't used it before. So it's predictable, it offers repeatability, and it offers reliability. And what we're going to be doing is we're going to be using Ansible to process each node in turn. It will quiesce the host, recluster, wait for the partition table to be updated on the client side, stop Aerospike, install the new version of Aerospike, and restart the node. It will then wait for any migrations to complete before moving on to the next node. All this while our 5K read and write process continues to run. And all this will happen without you seeing a single error. And for those who want to know how we wait for migrations to complete, the command is in the slide there. We monitor the output of asinfo -v cluster : stable, and ensure that it's not giving us.
Okay, so in this demonstration, we're going to upgrade our cluster from 4802 and the first thing we're going to do is we're going to change our dashboard. And the reason we're going to do that is I want to show you the version number. Okay, so you can see that we've got 4802 running on all three of the nodes in our cluster. Everything else is exactly as it was previously. 3 nodes in our cluster, 10 million objects. The cluster is static, no migrations. We've got our 5,000 reads, writes per second coming in. We've got no errors happening on the server side. We've got no errors happening on the client side. We are good to go. Okay, so there's the updates ticking away in the background. And this time, I'm not going to do anything on the cluster itself. So I'm going to log out. And I'm going to run my upgrade Aerospike playbook. I'm going to hit enter now, and as things progress, I'll explain to you what it is you're seeing. So let's remember what will happen. The node's going to be quiesced. We'll get a recluster event. The server will be taken down, upgraded, brought back up. We wait for migrations. You will notice that the terminal window is ever so slightly ahead of the dashboard. That's because the Prometheus agents sample every 15 seconds, so the terminal window leads the dashboard. So you will see some, dysynchronization, if that's a word, between the two. Okay, so we've done the quiesce, we've done the stop, etc. You can see the effects of that in that some migrations have come up. We've detected the fact that now there's a node down effectively, so the cluster size has gone down to 2, just 2 hosts over here.
key thing to note, our reads and writes just trucking along exactly as before. We've got no reads or write errors on the server side, and we've got no errors coming through on the client side either. Okay, so the upgrade is finished pretty quick. So what we've got to do is we've got to wait for migrations to complete before we move on to the next node. And I'm making use of Ansible's serial capability here. So by default, Ansible will work against a collection of hosts in parallel, but you can tell it to work serially, which is what we want to do here. So we're specifically waiting till the migrations drop to 0. And this will be quite fast because all that needs to be migrated in the cluster are what are called delta migrations, simply the changes that occurred with respect to node 3 that need to be migrated back to the node that was taken down. And we can see here that this node, it's already, it's now recovered, it's back in the cluster, change in the upgrade number, cluster size 3. As I say, we've got this slight lag here in that the migrations will now be at 0. And because of that, we've now moved on to the second node in the cluster. So we're going through the quiesce, recluster, stop steps right now. Again, you can see that the reads and writes going through just, without, as if, nothing like this was taking place effectively. 0 errors, server side, client side. We've taken the server down by this point, server number 2, and we can see it drop out in the dashboard. We can see migrations are taking place. As previously, the master objects, because the location of the masters is moving around and the sampling of the nodes isn't exactly synchronized, this number doesn't always show as 10 million in the dashboard. But if we sampled everything at exactly the same time, then it would do. So that's actually an artifact of the sampling. So we can see here, bottom, that we've brought the host back up. We just waited for the cluster to stabilize. We're just waiting for the migrations to complete. As before, it's delta migrations. It's all the content that went into hosts 1 and 3 that would normally be mastered on node 2, and that is now being migrated back, given that the node is now being restored to the cluster. We can also see that the version number for node 2 has also ticked up by 1, so 2 hosts are now running 4803. This kind of graph here is quite nice in that it shows us our cluster size, so we can see the the small drop down to 2 there and back up again, back and down there. We can also see the migrations ramping up, falling to 0, and then ramping up again now that we're doing the upgrade of the second host in the cluster. So now down to 187 migrations, so at this point it should move on to the third host, again slightly ahead of what you see in the dashboard. So we're doing our quiesce and stop. Okay, so the host has been stopped now, and we'll see it drop out up here very shortly. And we can see the effects of that because the migrations have kicked off. So it's going to be this host, 1001, that drops out this time round. So it will lag. There you go, it lags what's happening in the terminal window ever so slightly, dropped out, cluster size down to 2. Still no errors appearing on the server side and the client side. Okay, Prometheus has detected the fact that the node is now back, cluster size is up to 3, got our migrations. And then the last thing that we need to do is just wait while all those migrations wrap up. And then we have upgraded our cluster. I mean, without really breaking a sweat, without having to worry about orchestrating complex operations. I could have gone away and made myself a cup of coffee while that was happening. So note to self for next time. So we're just going to let that find its way to the end. Enjoy watching it. Okay, so I think that's pretty impressive. Personally, just being able to do that seamlessly and scripted and now. So in the next example, I'm going to show you how we can migrate to an entirely different cluster without experiencing any downtime or errors while continuing operations. So when might you wish to do this? If you were changing instance type in a cloud deployment, perhaps, in order to take advantage of new generation of instance types, moving to entirely new hardware locally, moving to a different data center. And you can also use it as a technique for avoiding rolling upgrades, such as the one I just did, or patching, particularly in a new cloud. Rather than doing rolling upgrades, you can just roll to an entirely new cluster and just turn the old one off. So to do this, as well as using Quiesce, we make use of Aerospike's rack awareness capability. So rack aware allows you to divide your cluster hosts into logical subgroups, and the server will ensure that for all objects, the master and replica are in separate groups. So if I divide my cluster into two racks, rack A and rack B, say, if I'm using replication factor 2, each rack will have a full copy of the data, and I can therefore remove a rack without experiencing data loss. Okay, so to migrate a cluster, the process is add new nodes to the cluster using a new rack ID, wait until migrations finish, at which point we'll have a full copy of the data on each rack, and then quiesce the original nodes. So it's as simple as that. I'll have a full copy of the data on my new rack. The cluster will then self-heal to ensure that we move to the state where we have fully replicated data in the new cluster. So we've got a demonstration of this as well.
Okay, so let's watch this in practice. As before, we have our 3-node cluster with our 10 million objects, and we've got 2.5K reads and writes per second going into the cluster. We've got no errors on the server side, no errors on the client side. So just to prove to you that these error graphs are actually working, I'm going to trigger some errors so you can see the graphs will actually show these things. And then we'll start with the demonstration. So I'm going to stop the Aerospike service on one of the nodes and start it up again. And we will see some errors because I didn't stop it in a graceful manner. Okay, count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Start it up again. And as before, there's just a little bit of a lag between what happens on the terminal, what happens on the screen. We can see the cluster size dropped, and we can see, yep, there are some errors coming through just on the right-hand side. So these screens are actually working, right? Okay, so you're looking at a slightly different dashboard again. Mostly so we can see the cluster ID and the rack ID 101 of the hosts in the cluster. Okay, so next step, I'm going to add 3 new nodes to my cluster. These nodes could be anywhere, same AWS region, different AWS region, different hardware, doesn't really matter. So I'm going to tag them with a
cluster tag, CL02. You see that, and I'm also going to give them a different rack ID of 102. So this script will do quite a lot of work. It will create 3 new instances, install Aerospike, partition the disks, sort out the config, mesh addresses, also put in place the Prometheus exporter. It will start Aerospike and it will update the Prometheus config so that it knows about the new hosts. So we'll just let it run all the way through. So now you can see the results of that just starting to come through. So we've got 3 new hosts in a different cluster, CL02, and they're in a new rack. So let's just note that we've had no errors throughout all that process, and also no change in throughput. And we can also see that we've got migration starting straight away. And as before, that master object total will fluctuate around the 10 million mark because the agent samples are not synchronized and the master object count changes on each node as the migrations complete. You can also see for the new nodes that the master count and the replica count is rising. Just watch that tick up on a couple of them. And on the old nodes, it's falling. So we're basically going to let this process of rebalancing, readjustment, run its course before we retire the 3 previous nodes. And once that's done, I'll have a full complement of data in each rack. So I can turn either one of the racks off as it happens. It will be CL01, cluster 01 that I turn off. Okay, so that is now done. I now have a full complement of data in each rack, which is equivalent to having a full complement of data in each cluster. So I can effectively turn off rack 1 or cluster 01. And I do that by running this script, which as before will quiesce each node, recluster, stop the server, and the instances. So you can see the Grafana display changing. We've lost our 3 original nodes, but note we still have 10 million objects, más o menos. The consideration concerning synchronization of agents applies. So I've got 1 copy of the data on here. And what will happen is the cluster will execute fill migrations. So all the partitions got promoted to master level. It now needs to create replica partitions. So you'll see, the fill migrations are executing now, and that will simply, run its course. And the net effect of what I've done there is I've migrated from one cluster to another. I've migrated from one set of machines to an entirely different set of machines. And we'll watch it run out. But as it runs out, as before, you'll see the throughput doesn't change, and there are no errors whatsoever. An entire cluster move with no downtime and no errors. Pretty damn cool. Yeah, so personally, I think that's pretty impressive. Just to reiterate then, Aerospike will let you avoid experiencing downtime or errors for all of addition of capacity, removal of capacity, product upgrade, OS patching, server maintenance, or cluster migration. With operations ongoing, if you make use of features such as quiesce or rack awareness. So some final points. If you hadn't spotted it already, the demos were pre-recorded. Firstly, to get them onto the platform. Secondly, to make sure that everything almost runs smoothly. You'll have noticed that I did speed things up in places, but I didn't do any cutting or splicing. So what you saw was exactly what happened, albeit at different speeds here and there. Throughout the demo, I've been making use of our relatively new Prometheus and Grafana stack, and I really recommend use of that. It ships with really helpful dashboards, and it's easy to create dashboards of your own. Grafana, if you haven't used it previously, includes something called Alert Manager, which allows you to build a comprehensive monitoring framework, and all this goodness is available at that GitHub URL. The next thing to say is that edge conditions do happen, network failure, for example, so please do take care with your scripts. And although I did say, I might go and get a cup of coffee while doing a cluster upgrade, in practice, I think I'd probably sit and watch it if that was happening in production. There's no substitute for testing, but the great news is that use of tools like Ansible allows you to test over and over again before you actually do something. Always use the latest Aerospike version if you can. In the demos, I used slightly non-current versions, 4.8, but that was just to simulate an upgrade. And that's pretty much it. So I hope you found the talk interesting. And it really should help you see that Aerospike is an always-on database, and there aren't too many of those around. So thanks for listening. And we'll take a few questions. And so I think my colleague Meher has been monitoring the chat. So Meher, do you want to pick up the first couple of questions from there?
Yes, thanks, Ken. So thanks. There's quite a few really good questions. There's one that came twice, actually, not surprisingly, about the Ansible script. So they're not currently publicly available, but please reach out. I'm sure there's different flavors of them all over from customers or from some of our own employees around. So for those specific ones, just reach out, and I'm sure we'll figure something. Let's see. There's one question that just came in, so I don't know if I'll have time to go through it since we're just out of time. So reach out. Hopefully, you guys saw all the question and answers, and we'll definitely take those offline since we're not, unfortunately, out of time.
Right. As Meher says, we have got to the end of our slot, so thanks everybody for attending. You should be able to find me easily enough. If you want your questions answered, we'll do our best to respond what's in the chat. But enjoy the rest of the summit. Have a good day.